In this video, we're going to learn how to factor trinomials. Trinomials, this word tri means three and nomials means term. An example of a trinomial might be x squared minus 7x plus 12. There are three terms. Okay. First, a reminder of a definition. Factors. There are two terms that multiply to give a product. If we have 4 times 3, that's equal to 12. We call 4 and 3 the factors. 12 is the product. An example using polynomials might be this. If we have x plus 4 times x minus 7, well, we know using the distributive property, we'll take x and multiply by x and get x squared. X times minus 7 is a minus 7x. And now I will distribute the 4. 4 times x is a plus 4x. And 4 times minus 7 is a minus 28. Lastly, we can combine these two like terms. Minus 7x plus 4x is a minus 3x. So we have x squared minus 3x minus 28. X plus 4 and x minus 7, these are factors. We multiplied these two expressions together to get this trinomial expression on the right side. This is the product. Well, in this video, we're going to learn how to go in the opposite direction. We're going to learn how to take this trinomial and break it up into two binomial factors. All right. First, we're going to need to be reminded of our standard form of a quadratic. Standard form. Standard form of quadratic. Well, our standard form of a quadratic is ax squared plus bx plus c is equal to 0, where a is the coefficient of the quadratic term, b is the coefficient of the linear term, the first power term, and c is the constant. I'm going to show what I'll refer to as the big X method. For factoring quadratics. In some books you might hear this called the AC method. Okay, it's just an algorithm, a method for factoring a trinomial. Alright, in our big X method we're going to start by drawing a big X. And this big X has nothing to do with the fact that our variable here is X. This is just a little chart for separating out our terms. In our big X method, we're going to put b from this standard form in the top here, and then in the bottom we're going to multiply a times c. A times c. Alright, and our goal is going to be to find some terms that multiply to give this, and then add to give this. Alright, let's do an example. Okay. Example number 1. Let's say we have the one that we started with earlier. We have x squared minus 7x plus 12. I'm going to begin by drawing my big X. Alright, in the top goes my b term, which in this case is negative 7. Remember, b is the coefficient of the x term. So in the top I'm going to write negative 7. In the bottom, I'm going a times c. In this case, a is an implied 1, a the coefficient of x squared, an implied 1, and c, the constant, is 12. So 1 times 12 is 12. All right. I'm going to choose numbers that will multiply to give this 12, but then add to give this minus 7. So what I do first is think of the factors of 12. What numbers multiply to give 12? Well, 12 times 1 does. 6 times 2. And 4 times 3. But I need to add to give this negative 7. Well, in order to multiply to give a positive 12 but add to give a negative 7, these two numbers are going to need to be negative here. So really I'm thinking which of these numbers, they'll all multiply to give 12, but which are going to add to give 7? Well, clearly 4 and 3 are going to add to give 7. 4 and 3. So what we really have here is a negative 4 and a negative 3. That is, they will multiply to give 12. Negative 4 times negative 3 is a positive 12, and they'll add to give negative 7. Negative 4 plus negative 3 is indeed a negative 7. So these are going to be the constants inside our binomial. Thus, equals, I go two parentheses, because I know this trinomial is going to break up into the product of two binomials. We've seen that many times. Whatever this variable is will be my first term. And these two things we just found will be the second term. Minus 4 and minus 3. And it doesn't matter which one went where, because as we know, multiplication is commutative. I could switch these two terms and it would give the same. I'm going to verify that this trinomial is equal to the product of these two binomials. X times x is x squared. X times negative 3 is negative 3x. Negative 4 times x is a negative 4x. Negative 3 and negative 4 will yield negative 7. Negative 4 times negative 3 is a positive 12. All right, let's look at another example. Example number 2. Let's say we have m squared plus 11m plus 24. All right, again, first I come with my big X. In the top of my big X, I'm going to just draw a little separator line so we don't get confused here. Okay. In the top of the big X is my B term. A is 1, B is 11, C is 24. So here goes an 11. And it's a positive 11. The signs are so important in this case, it's good, even though we assume that 11, when we say 11, we mean positive 11. I'm going to emphasize my signs because they're going to be so important. In the bottom is A times C. 1 times positive 24 will be a positive 24. All right. We want numbers that add for this one but multiply for this one. The key is to start with the multiply. Think about numbers that multiply for 24. Well, that's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are all of the paired factors of 24. They will all multiply to give me 24, but only one pair will add for 11. That's 8 and 3. If the bottom term is positive, the signs are going to be whatever this top term is. In this case, it's a plus 3 and a plus 8. Positive 3 times positive 8 is a positive 24. Positive 3 plus positive 8 is a positive 11. These are going to be the two constants in the binomial factors. So, two parentheses. We want to get an m squared, so we know it's going to be m times m. And then simply these two are the second, are the constant terms, plus 3 and plus 8. Again, using our FOIL multiplication. First, m times m is m squared. Then the inside 2, 3m, and the outside 2, 8m, add for 11m. Lastly, 3 times 8 is 24. Okay, one final example. X squared minus x minus 12. Okay, we start with our big X. In the top is b, and b in this case is a -1. A is the coefficient of x squared, b the coefficient of x, c the constant. B is -1. In the denominator, it's a times c. That is 1 times -12. That's a -12. All right. I want to find numbers that multiply to give 12. When I'm thinking of the factors, I'm not going to worry about the sign. I'm just going to consider the absolute value. The paired factors of 12 are 12 and 1, 6 and 2, 4 and 3. I could introduce negatives with each one of these and look at another 3 pairs, but I find that to be confusing. What I do need to know is if this is a negative, one of these will be a positive and one a negative, because to multiply to give a negative, signs must be different. Now, I'm adding for this term. Since these two signs are different, when adding unlike signs, it's really like subtraction. So now what I'm choosing are two numbers that subtract to give subtract to give 1, essentially. In this case, 4 and 3. Well, if we're adding unlike signs and the sum is a -1, we want more negatives. So 4 will be the negative and 3 the positive. Positive 3 times -4 is a -12. Positive 3 plus -4 is a -1. These two here become my constant terms. So 2 parentheses. X squared is going to be x times x. Plus 3 and minus 4 are the constants, and it doesn't matter what order they're in. All right. Using the steps that you've seen here, you should be able to factor any trinomial as long as it is in the form ax squared plus bx plus c, and a is equal to 1. The process is a little more difficult when a is not equal to 1. I will make a separate video to show when this value here is greater than 1.